So welcome. So my pleasure to do the webinar for the RTM today, where we will discuss the data analytics for operational excellence with RTM. My name is Filip Simunovic. I'm a part of the operational excellence team, and I'm consulting other companies in data analytics and how to improve their processes. The agenda for today, we'll have an introduction about our company, Applied IT, then just a short introduction in what are the problems and how we approach those. And then this is not going to be a presentation or a PowerPoint presentation only. Of course, you want to see the RTM Pro, so I will switch to RTM and I will guide you through the software, show you some things. And then we'll have some time for questions and hopefully very good answers from my side. So please, again, I already told it once, but feel free to put in questions if you have any, and I'll try to answer the best I can. And then just finishing up with the RTM Pro resources, where can you find us, and so on. So about Applied IT, what do we do? We are experts in problem solving through data analytics, problem solving on the focusing on the complex problems. So not problems that you can solve with your typical, I would say 5Y Ishikawa methods, but more on the complex problems, so multiple processes which are interacting together, causing problems. Together with the data analytics. So our method is based on data. We are only taking decisions based on data. So that's the base of our method. So we're trying to combine the engineering skills, so knowledge about process together with the data. So we have both sides, combining them into one and structure a problem and then solve the problem step by step. We are closely working with companies together on continuous improvement. So not on only problem solving, but also performance problems. Try to identify them and then attack those bottlenecks to solve them. We always have a close cooperation with the companies as we don't own the process itself, but of course we need that information. So it's always a close cooperation. It's not like companies give us the line and then we try to do something. So it's always a combination of those two. And we try to develop services and products which helps you to solve problems, to see real-time trends and make data-driven decisions based on that. We have a lot of different partners, which you can see on the right side over the last 10 years of Applied IT, which we had the pleasure to work with. And also we have the privilege that we got some really good feedback. Just to show some highlights of our customers here. Going into the introduction of the topic, the everyday struggle with data. For one, we have fragmented data. So we have multiple sources of data, report silos, and that's causing a big challenge because you want to combine all those and make basically decisions based on all those data, which are in different silos. We need to put them together to make data-driven decisions. Also, no early warnings. So worst case scenario, you produce the whole day. End of the day, you see a big red number of, let's say, 50% scrap. And so you wasted basically half of the parts of that day. Another problem is the manual reporting. So still a lot of companies are using manual inputs, for example, like a basic Excel sheet where you try to track problems or scrap parts, whatever. This is not the best solution, as of course, if you're inputting manually, it's driven to have some sort of input errors, and you will not be able to track that on the long term. And then the slow reaction time, which I already mentioned. So if you produce a lot of scrap, you want to know right away and act based on data. You want to react really fast. So how to transform your daily work? Yeah, basically all those problems that I showed you before, you want to avoid. You want to have early warnings in real time. You see you have a problem at the line, 2-3 parts. You get to the line, you stop the line, you have a look. Or best case scenario, you look at the data and you know exactly what's wrong. Is there a trend of a certain parameter? I have to correct it. And that's the way you want to go. You want to have a centralized data, so put all those different stations, different lines together, connect them through, for example, batch numbers, part IDs, and have a look at that data. Automated insights, so less Excel and more kind of a software where you can track everything. You have your database in the background, which is providing the data, and you just analyzing the data, which helps you to have faster and more proactive decisions, which are all based on data. And yeah, that's like a basic introduction, and I will just jump into the demo as time is limited, and I want to, of course, not talk too much, and just show you the RTM itself. So if I just click outside to show you how does it look like. So basically the RTM layout, you can open a new connection here. Of course, if I already opened a database, there's the possibility to just double click and you will see it will open up here. Also, for example, if you have a certain files, for example, if you have a basic Excel file, you could also import it. So it's not necessary to have a database. Of course, it's helpful. And if you want to have automatic real-time insights, you will need a database. We are usually working with an SQL database that is working in the background. And then you will have the possibility to connect that SQL database and then connect to that. But however, if you have, for example, a certain Excel file, you could lock those in, or you could import that file. It's only necessary to have the ID and the date stamp. However, there's also the possibility to generate those two. So just click into the demo database and show you around. So what do we see? We see on the left side, we see the filters. So if I click in here, you can select a certain time frame that you want to have a look at. So for example, if you want to have a look at the last production, you would just select yesterday in that case. All different possibilities to select here. If you click on the min max, it will just select the min and the max of the data that you have in your SQL database. So in that case, it's just a demo database, but it's running in the background. So just a few days, and I will select that time frame. And then on the bottom left, you will see the certain stations that you have. In my case, it's those are 5 stations. And if I click on the plus here, you will see all the parameters that I have for that station. So for example, I have a material type, and there are 3 different kind of parameters that I have. One is the blue, which is categoricals. So if I click, for example, on the type, material type, it will just show me a Pareto of the different categories that I have. So I have material 2 inside this station, and I have material 1. I'll also see how many. So in that case, 1,184 parts, which ran with material 1, and material 2, the 1,264. I also have black parameters, which are numericals. So if I double click on those, for example, for the position X, you will just deselect that and calculate again. You will see a run chart. You have an ordinal axis, but I can also switch to a time view, where I will then see basically just a run chart throughout the time that I selected of this parameter. Quite interesting right here is already this kind of drop. Well, I will show you something later on. And then the last parameter that you have is a time frame. So those are the red ones. So if I double click, it will also show me a kind of counting up just the time frame. So it's not very interesting, but just to show you all the three categories that I have. Essential for the RTM is, of course, my settings. And for that, I need to select the date and my ID, and then have the possibility to order by timestamp, for example. You can also order by other things. And the status, the yield is important if I want to use certain functions. One of the first functions that I want to show you is the CTT. So as you see here, I have the 5 stations. I want to look, for example, for the end of line. CTT. What is the CTT? The CTT is basically 24 hours of production. So I cycle time over time. I see on the x-axis, I see 24 hours of production. On the y-axis, I see the process time of that station. We are counting here end timestamp to end timestamp, and all those blue dots are essentially parts. So if you can also see, if I click on a part, the serial will appear here in this search bar. What can I see also? I can see the output per hour. So starting with 19, then the maximum for this day is 36. And basically the output per hour on the top. You also see the histogram here next to the CTT. And then the interesting part will be here. So we are calculating the cycle times on percentiles, and usually the two that are the most interesting are the P10 and the P15. So the P10 is the 10% parts which ran the best or the fastest throughout the station, and we call that the technical limitation of that station. That means that if everything is good, my station has enough material, it can produce on the P10 level. And that's more or less, if I put here a line, it's the 100 seconds, which you see here. So this station can perform on 100 seconds per part. The P15, I mean, in that case, it's very close to the P10, but the P50 is more of the, let's call it the line takt, so the flow of the part. So we have logistical influences in our process, and the P15 will be reflected in that. So it's the 15% best case or best parts which ran through my station. And maybe I show just another example so you can see a larger difference. For example, for this one, you see that the P15 is 10 seconds separated. So that's actually the flow of the line. So that's in a real case throughout the day, in which time does my part get through that station. Of course, it's interesting to see the P10 and P15 for all the stations. So how do I do that? I just click on the OEE components, for example, and it will select for the value OK status 1. And you will see all the 3 components of the OEE. So you have the performance in the left top, then the quality here, and then the downtime, the lost time minutes per station. So what do we see here? We see that the station 4 has the highest P10. So that's the technical, the station that is limiting my output. So the bottleneck station of my line. And that would be a first indicator where to focus on. So I need to reduce the P10 of that station to have more output of my line. Yeah, basically, if my P15 and my P10 are very close, that means that I have a technical bottleneck. And if I have a high discrepancy between those two values, for example, for the end of line station, you can see that the P15 is much higher. It essentially means that my station is starving out of parts. So the potential of that station is higher. It can perform quicker, but it's just not getting enough parts. And I have a logistical bottleneck at that station. You can also see that I have the quality overview. And for example, what you see is that the end of line is performing the worst, which is, yeah, of course, not the best because it's at the end of the process. And if I have quality issues, I want to have them at the start. So it's not, yeah, the costs are not too high. So I want to look at the quality for the end of line station. How do I do that? I have the function which is called quality analysis. So if I click on here, again, I have to select the OK status, put it to 1, and then it will give me an overview of that station. So how many parts in total did I run through that station? How many of them were OK? Then I have repeated OK. That means my part ran through the part. It was OK the first time. However, it ran another time and was OK again. So yeah, just maybe some small batches, or for example, a golden part which ran through that station. I also have recovered serials. So first time it was NOK, and I repeat the test on that station, and I have an OK status. And then you see the total of NOK series. All of those informations are also in the summary here. And yeah, I want to look a little bit more into detail into that. So we'll just select this at the second station and perform the quality analysis here. Select this one as an OK. Okay. And for example, you can see that the station 1 is performing on 88 first time quality compared to the quality of station 2, which is at 85%. And I want to have a look at the yield. So the yield, I see the OK parts and NOK parts. I see how many of them were OK, NOK. I switch to the, no, actually don't. And I just want to move this to the side so you can see much better. So I have some icons here, and what I can do, I can run a group analysis. So I want to select 2 groups, which I put with this box select. I select the good parts first, which will be blue. So select the box, I press G on my keyboard, and I do the same thing for my NOK parts here, which are red. If I press A, it will basically run a group analysis of those 2 to see what's different. So if I make this a little bit bigger, it will be much easier to see. And what I want to look at is, for example, the P-well, and the end count. So the P-well has to be low, and basically it's a statistics which is comparing those 2 groups that I selected to see what's different. That's the way we approach problem solving. Is not what's wrong, and it's rather what's different, so we can eliminate certain processes. And what I see here is, for example, the working current, which is where we have a difference. I see here the end count is essentially the separation of the 2 groups. So the higher the end count, the better, as I have a higher spread of those 2 groups. So I will look now into the working current. Just here, I'll double select here. One. I'll do the same. Okay, and I see something very interesting here based on the group that analysis that I showed you before. I saw the working current, which is one of the differences. And for example, this group is quite interesting. So what I can do is again select two groups to see what's different here. So let's select this as a group and this as a group. And I run the group analysis again, but I don't want to just look at that certain station. I want to, because basically that's the outcome which I see, or the symptom, but it's not the root cause. So I want to run the group analysis not only on the on this table, on that station, and I want to have a look at all the stations. Of course, I have here to accept the filters that I activated. That's fine. And then I sort again by the P-well. And what I see is of course, I see my working current because that's the two groups that are selected. Of course, those will have a very high end count. But what I also see is that X position in the station one. So I see the separation is quite good. I have a very good p-val. So certainly there is something. How do I run with the RTM this separation? I can also select the wise by output. So basically it's separating or searching for the part with the most separation. So I see the contrast even clearer. So if I click onto that, I have 5 parts. If I go up to 10 parts, it will show me the separation, the highest separation of 10 parts each, and I can run the group analysis on that, so I can see even clearer the picture. Of course, I have to select all here, one again, and I hopefully see the X position popping out again. And I see it here. So quite clearly, I selected two groups, and out of 10 parts, so I have the maximum output of or end count of 20, so 100% separation of those two groups. So certainly there's an interaction between the X and the current working. So what I can do now is I can select the working current as a Y and the X position as a Y. Then I run a multiple Y chart. And that's clearly showing me the interaction of those. Maybe it's better in that way. So you can see if the X position is going down, my current working is going up. So I'm going to switch. But you clearly see that interaction of those two parameters here. So that would be one of the examples to how to solve with data analytics such a problem. So I started with a group analysis. I checked what's different between those groups, and then got into separated even more the groups, so I see it much clearer. And then I have the possibility in RTM to select those parameters, check them, and then one of the first steps would be, based on that analytics that I see here, is go to the X position in the positioning, making sure it's running in a certain tolerance, so I don't have the problems in the end of line station. I also have the possibility to monitor this with the SBC. where I can select certain rules. There are 10 rules that you could select. Yeah, you can see the Nelson rules right here. For example, rule 2 is 9 or more points in a row are on the same side of the mean. So what you see here is, for example, drifts. So if I want to see a certain drift, I will select the rule 2. Maybe put this up to a group of 25 parts. And you would see certain drifts which can then be identified based on those rules. I also have the possibility to have like a SPC monitoring. So if I know that my position X, which is important for my current to work, so I have an OK status in the end of line, I can drag in the X position of that station 1. I can select the rule that I want to have. I had the rule 2, for example. Also put the subgroup size to 25 again. I can also work on the tolerances, for example. And what I can do now is I can put in my email address, for example. And if I edit, start the SPC monitoring, there is the possibility to be notified. I will then, if this rule is met, I will receive an email with an automatic report, which is showing me the data analytics and informing me there's something wrong. Please have a look. Go to that station and have a look at that station because we're moving into the wrong direction. So yeah, that would be one of the use cases that we have. Of course, there are other functionalities that I could show you. For example, the OEE gap analysis that we have for a certain station. So I want to have a look at a certain station and see where I am losing those parts. If I just click and I select again the one as the OK, I want to produce 5,400 parts, for example, and I calculate. So I have the target here, and then I see the three OEE components, the quality, then downtime, and the performance, and I can identify where to focus on. Of course, those NOKs, are hurting a lot at the end of line station, so that would for sure would be one of the focus. But then again, I'm losing a lot of time due to downtime, so that would be another improvement which I need to make. I see the OEE of that station based on the target, and with all those numbers where I am losing those parts. So the yield here is what you get out based on that target, and then those are the losses of parts per category. So for the quality NOKs, I would lose 195 parts, rework 61, and so that's a target. That's what I'm getting out, and those are the losses that I have based on that target. So yeah, that's some of the functionalities in a nutshell. I would like to see if I have questions. So if you have certain questions, it's also much easier for me to show you in RTM what is possible, what can we visualize. So as I showed you, the CTT, there's also the possibility to track a certain part. As we have the part which is connected throughout all the different stations with the part ID, I'm able to track it. So if I'm interested in a certain part, I can input the part ID. So imagine you have a recall. You want to have a look at the parameters of that part. You can input the serial number in the search bar here, or if I just want to look at a certain part which is looking funny at the CTT, I just select it and it's popping up into the search bar. I want to look at that part. And what I see here is I have all the tables, so all the different stations and all the values that I see for that part. So the full traceability of that part. So if I select, for example, the pressing, I would see all the different parameters that I have in my table. I will see the value of that. For the screwing, of course, I will also see if one of those parts ran multiple times. So you see the value 1 here. If, for example, for the leakage test, we have a repeated cycle, I will see a value 2 with the corresponding parameters here. I can also do the time frame visualization to exactly see how much time did my part spend at which station. So for that selected part, I see that I spent 1.6 minutes at the station 1, then 2 minutes at the station of pressing, then around 48 minutes on the station 3, and then just over an hour or just an hour on the station 3. So you just see the flow of the part throughout the line. I could also select this search special event to see if there's something special. And yeah, for this part, it's not. But there's a possibility to check if, for example, if this part, one of the parameters is running in some direction, positive or negative, and you could see that with that functionality here. So maybe I think that's one of the, I would say, last more simple functions where you just need to click. Of course, we have a lot of different functionalities with advanced where we are using call it more mathematics and statistics, which is running in the background. But of course, I just showed you the simpler ones, which we are using on a daily basis. So I think that would be it from my side of the presentation. If there are no further questions, if you want to have a look at certain things, of course, I'm very happy to show you. How often do you face late detection of scrap or quality issues? I mean, it's always depending, because maybe you see the scrap, but the thing is that you certainly don't see certain drifts. So what I can do here is that, of course, I mean, most of the companies know OK and NOK, but what's the problem of that scrap? That's the biggest question. And with RTM, you could detect such drifts very easy. You can compare OK to NOKs, you see what's different, and then you can go to that station and have a look at it and put it into a certain tolerance back, so you don't have that scrap. I just had an example last week where 2 lines which were running, and then just in the second line at the end of line station, they had a problem. We were then able to track it back and see that the problem was caused at the station 1, but was just detected in the second line. So it's not rare that you detect a problem at the end of a process or a production line, but actually the problem is caused in another station. And those are exactly the complex problems, because if the causal station and the detection station is the same, it's more, I would say it's a simple problem, and you can detect that quite easy. But if you have an interaction of multiple stations, multiple lines, in worst case, it's much more common. and you wouldn't be able to detect it just at looking at the station, because at one station you're just detecting it, but actually the scrap is caused in another station. So I hope that is answering your question. So then I think I would close this meeting. I think we're pretty good in the time. I'll just be here for another 2-3 minutes. So if there are any questions, I will answer them. If not, thank you very much. And of course, there's an information where to find us. So I will just maybe show last thing, the presentation. Where do you find us? We have an a web page, Applied.it. You can see the browser here, where you can find us different blogs, articles where Luis and Laura are providing based on the information or the action that we have on the field in a blog style here. And please follow us on LinkedIn as well. And if you have any more questions, maybe that come tomorrow, feel free to reach out via LinkedIn, email, whatever. I'm happy to answer your questions or your needs. If you have any special needs, please reach out, and we can align on a meeting, see what's possible from our side. What do you need?